This is how you would do phase modulation with SynthMaker. This is version 0.1.50, and here's an example which I will start from scratch and explain on the way. But we have a knob that controls phase that goes from 0.01 to 0.5, where 0.5 is 180 degrees, and there are two sawtooth waves. If we have this amount at 0, the second sawtooth wave is not being added. This is the amount of the second sawtooth that is being added. So you see here we only have one sawtooth. This is the phase of the second sawtooth compared to the first one. If we would go down to 0 with the amount at 1, they would just cancel each other, so this knob doesn't go all the way to 0, and it goes all the way to 0.5, where you would get the square wave. Okay, so I'll start with a new empty schematic to explain how to achieve this and how it works. So I'll close this one. So I'll start with SignSynth to save time, and as input I will use the computer keyboard. So keys come in here. You can actually monitor these keys. There's a key monitor there if you want, and you can see them coming in. But we want to convert these keys to MIDI. So there's this key to MIDI, and now we have MIDI messages going to our synth, and audio out, plug it, check if you can hear something. Okay, so this is our SignSynth working. Now we go inside the SignSynth, and this is the schematic for it, and these components are minimized. This is our audio out. This one adds all. You can see these connectors have a square, which means they have 16 voices. They're like an array of voices, and these are a circle, which means there's only one voice on each. That's your left channel, right channel, and this one is multiplying. There's two inputs, one output. It's multiplying your envelope with the wave. This is an attack, decay, sustain, release. You can look at the labels and you can maximize them. Like here you could maximize this ADSR, and you could look at the labels like this. They're in the wrong place. That's a bug. Okay, so I'll hide the labels. So we have a phaser, and this is MIDI to voices. So our MIDI messages come in here. You can see it goes bright red when they arrive. These MIDI to voices, if you look at the labels, you have a frequency, you have a gate, velocity, pitch, and note. These pitch and note are the same, except pitch is a float, note is an int. You can actually look at all these values. There's some new components that you can look at, which are called here on the display. You can show, for example, show floats, and this will show, if we connect to there, you'll see the frequencies. You can see that they stay, the frequencies stay. When you release the note, they stay, because you might have oscillators that are running even when the note is not playing, because they can be used for modulation, and they can be used even when the note is not playing. So now if we use pitch, you can see pitch is a number which is the equivalent of MIDI note. but it's a float because you'll be able to modulate your pitch, like filter cutoffs and stuff. So it's useful to have it as a float. And you can see them. For example, if we look at our phaser goes from 0 to 1, and it wraps around, also keeps running. And the result of our sine wave, it goes from -1 to 1. And when we look at it after the multiplier, because it's gone through the envelope and the envelope goes to 0 when you're not playing notes, you'll see that the notes go down to 0. While before here they don't. They just stay running. So these are like 16 voices that are constantly running. Now, okay, so another way you can look at this is with scope, like scope wave. And the scope wave needs a gate because it shows the last one that is played. And you could get your gate from there, but it makes it tidier to use this gate RX, which is the same as being connected to there. And now we can look at, for example, the wave coming out of the sine. You see, when the note is not playing, the wave is still there. But if you look from here, you can see the release makes it go down to 0. And if you look at the phaser there, sorry, no, this is the sine wave. The phaser comes out of there. You see it goes from 0 to 1. So basically it's like the phase you use for a sine wave. Normally it goes from 0 to 2 pi. Here it goes from 0 to 1. Okay, so it's quite useful to look at these waves and to have them pinned as you go down the hierarchy of your schematic. You might want to be looking at them. So there's this pin, and you'll see it there. And you could have another one. So that's for your phase. And then you could get another one for the wave, the sine wave. And now I'm going to also pin it there. And now you can see the connection between the two. The sine wave goes from -1 to 1. Your phase from 0 to 1. You can resize this. Oops, not. You can resize it here. Okay, so this is how phase works, and we're using a sine component there. pH sine. pH is because it takes a phase. If we want a more generic wave, we would, instead of a sine component, we would use a table oscillator, which is here on the phase category for the primitives. You can see there's these two. There's the pH table X4 and pH table OS. The X4 has 4 tables, and it modulates between the 4. For this example, I'll just use 1 because it's simpler. I'm going to delete the sine wave. So we connect the phase, and I'll show the labels. There's the number of harmonics, which for now I'll make it like fixed number of harmonics. Let's say 10. And then this component needs also a table, which I will show in a moment. And this is what comes out. So at the moment you won't see anything. I'll connect to this one to our wave. Actually, you can name these so it makes it clearer what they are. So this one is the phase, and this one is the wave. So now here you can see phase and wave. Okay, so at the moment we have a phase, but nothing comes out of our table oscillator because we didn't give it a table. There's a way of giving it a table, which is this, where is it? Inside the phase category, wave selector. This component is made to select between 4 different waves, and we're only going to use one of them. And in the future there will be a simpler version of this component that will just have one of these table outputs. So when you see, when I select a voice, this goes red because the table went through it. You can already see it playing there, and it's still, that's a sine wave. But if we select let's say sawtooth, and we can look at the FFT, scope FFT, connect the gate again so that it does the last voice played, and now our wave goes there, and I'm going to put the FFT pin it there as well, make it a bit bigger like the other ones, and I'll call it FFT. And you see there's the 10 harmonics that we're specifying here. If we want to go for like 20, we now would have 20 harmonics. But we want to have all the harmonics all the way to the end without aliasing. And to do that, there's this frequency to harmonics, which from a given frequency calculates the number of harmonics, maximum number of harmonics without aliasing. And now you see it goes all the way. Okay, so far we don't have any modulation. We want to create some kind of modulating a wave, which we're going to add with this sawtooth. So we're going to invert a sawtooth, add it to another sawtooth, change the phase, like the angle of the phase, so that when you add them up, you'll be able to generate a square wave where you can control the pulse width, as you'll see in a moment. Now, it's one thing that's useful here is to create all this inside a separate module. Otherwise, it gets schematics get quite complicated. So I'm going to delete this stuff here. Might leave those so we can use them when we have our new module. So to create a new module with a user interface, you go to this view component, and we want our view component to accept a phase. So I'm going to give it an input, and to accept the result is the wave. Now this is a phase here, so I'm going to change it. So to test this, first I'm going to just put here a sine wave, just see if this works. So now our view accepts a phase. I'm going to give it a phase there, and that's the result. And I'm actually going to plug these to our wave and FFT. So now we have our sine wave. We can see our phase, our sine wave, and our FFT. and it's all comes, this sine wave is all generated inside our new module. Instead of a sine wave, we want to have an oscillator, and again I'm going to use this simpler version and connect this. And for the number of harmonics we will need another input so that we know the frequency. So input, this will be our frequency, and this one will be our phase. So from the frequency we need to convert to the number of harmonics, frequency to number of harmonics, and now like before we need to give it a table. Phase wave selector goes here. Now I'm going to give it sawtooth. Okay. Oops. And you can see this is clearly aliasing. That it's like bouncing at the end and sending harmonics back, and that's because we didn't connect our frequency over there. So you'll see the difference when we connect the frequency. Now it's very clear. It's a clean wave, no aliasing there. And okay, so now actually if we could delete this wave selector, once this table has this table oscillator has the table inside it, it will keep it there, it will save it, it will load it. This can be thought as a temporary component unless you plug it to your UI, and then it would become a way of changing your table from your synthesizer's user interface. Okay, so now we want to have an inverted sawtooth. This sawtooth goes up and straight down, goes up at an angle and straight down. If we would do an inverted sawtooth with the same number of harmonics and with the same phase, and now we would multiply it by -1. For now it has to be done this way. In the future you might have just a multiply component or even an invert, which should straight away multiply it by -1. But for now, do it like this. And now instead of that sawtooth, let's look at this. And now this didn't do. Oh, okay. So I didn't give it this table. Let's make it go there. Yeah. So now we have the inverted sawtooth. Now if we would add these two together, they would just cancel each other. So let's see, add. Now we'd add one with the other, and now they cancel each other. There's nothing coming out. But what we can do is change the phase of this this second one, so they will add to each other out of phase. So the phase comes here, and now I'm going to add for example, if I add 0.5 to the phase, it would become 180 degrees, 0.5, and now we have our square wave. If I do 0.1, we can see the width of the square wave has changed. It's now much smaller. Our FFT still looks good, clean, without aliasing. And to change the pulse width, we could then use the knob. This knob would be connecting to there, it goes from 0.5. So at 0 they cancel each other. At 1 they cancel each other because 1 represents 2 pi. So 360 degrees plus because it's being multiplied by minus 1, they would cancel each other. So in our knob we could control the minimum and the maximum here, so that they don't get to that point where they cancel each other. I think here I will leave it so we can try it out. So if we want this knob to appear in our module, so our module has nothing in the user interface, we'd connect it to there, and now we have it here. So now we could close our module and 0 cancel each other. At 0.5 we have our square wave. Okay, so if I go back in, I'm going to call this knob phase, and also here this is our synth, which we could show in, we could pin it so we can see it here. It has nothing, but we could connect our new module to our synth. So our synth now is this phase control, which we can then use it here. Okay, so now we could control also the amount of the second sawtooth that we're adding, because if we're adding 0 we just have the first sawtooth on its own. This would be a way of modulating between just a sawtooth and a square wave with PWM. So for example, let's say if we have 0.5 of the second one, and also here we could use a knob, connect there, and this would be the amount, this knob would be the amount of the second sawtooth. Oops, not this one, sorry, this one was the phase. It's this one amount. So now we can see how the amount at 0 we have a sawtooth. Amount at 1 it goes to fully adding the two. So in this case with a phase that's, let's say, around 0.5, we have our square wave. And we want to have this amount knob also in our synth interface. So instead of connecting to phase, we could connect to H stack, so that they will be horizontally together so they'll be in a horizontal stack, and now connect to there. And now we can control here the phase, and here the amount. So from sawtooth to the square wave. We can see that on the FFT we can see the harmonics going from you see, when you go to a square wave, you have about half the harmonics of a sawtooth. Okay, so next thing that could be done would be to use LFOs and envelopes to modulate this phase control, but I'll leave that for another time.